All right, so limit definition of asymptote. Okay, so the line y equal L is horizontal asymptote of the graph when the limit of x approaching to infinity is equal L or limit of x approaching to negative infinity is equal L. So either one of these, you're gonna have a horizontal asymptote. Okay, it does not necessarily to be one of these graphs. It could be anything as long as the you can have a behavior of the graph like this. And then, but when it go to a long term, it just happen to approaching to one value y. Okay, very closer. Then you're gonna have a horizontal asymptote at y equal that value. Okay, so we are finding when x approaching to really, really large, what is y approaching? Okay, if it's approaching to a certain value, then we're gonna have a horizontal asymptote. Okay, and before we apply to finding the limit of those or finding the horizontal asymptote, we want to see some important information first, some basic rule of that. So if you have a limit of x approaching to infinity of x to the power n, right, a positive infinity, of course n gonna be have to greater than or equal 1, then your limit will be approaching to infinity. Okay, but if you have x approaching to negative infinity, x to the power n, and your n is when it's a negative infinity, then that's gonna be different, right? So when it's a negative infinity, if you have the power is even, then it's positive infinity. But if you have power is odd, then that's gonna be negative infinity. Okay, so if n is even, equal to positive infinity if n is even, and negative infinity if n is odd. Okay, and if you have a limit of x approaching to infinity, positive infinity or negative infinity of 1 over x to the power n is going to be equal to 0. Because if you have a fixed number and then you keep dividing a very huge number or a negative huge number, the value is always approaching to 0, a very small value. So it's most likely 0. Okay, so then we're going to have that equal to 0. And then this apply for the negative infinity as well. Okay, and one more thing, which is limit of x approaching to approaching to infinity of e to the power x, then it's gonna be infinity, right? Huge value, or a to the power x is also a huge value, and limit of x approaching to negative infinity, e to the power x will be 0 because it's on the other side of the graph. Okay, so there are many more, but we're gonna just use that, some basic of that. And then let's take a look at this problem. So I want to find the limit of x approaching to infinity of 5 minus 3 over x squared. Okay, so the limit subtraction, we know that we can actually break them down to limit of x approaching to infinity of 5 minus limit of x approaching to infinity of 3 over x squared. Okay, based on the limit rule, we know when x approaching to infinity a constant, limit of a constant is constant. Okay, recall that. Recall limits of constant is constant. Okay, so this means limit of x approaching to whatever of a constant number is the constant itself. So it's going to be 5. Minus, what about this? What is the limit of x approaching to infinity of 3 over x squared, which is on this one, right? So the denominator is getting really big, really big, and the numerator stay the same. So it's going to be 0. So the answer will be 5. So you have a horizontal asymptote. So we can conclude that there's a horizontal asymptote at y equal 5 for this function. And we can also actually double check that with the decimal and see, do we get the right answer? So 5 minus 3 over x squared. Okay, so you can see when x approaching to infinity, your y value approaching to 5. Okay, and that's what we get from the result. All right, so that is the first one. And then now for the second one, I have the limit of x approaching to infinity, 3 over e to the power x. So yes, e to the power x, when x approaching to infinity, e to the power x getting huge. So you have a constant divide huge number is actually 0. So you can just go ahead and say 0. How about limit of x approaching to infinity of x to the power 4? So let's think about if this is 1,000. 1,000 to the power 4 is a huge number, right? And also when x approaching to positive infinity, x to the power n, the answer will be infinity. So your y value will keep growing when x growing. Okay, and similarly for x approaching to infinity of x cubed, the output is also huge. Now, how about this example? I want to find the limit of x approaching to 2x minus 1 over x minus 1. So how do we do this? This is a fraction. So it doesn't look like we have anything like 1 over x to the power n or x to the power n. So when you see the fraction like this, if we want to find out is there any horizontal asymptote, we can try to divide every term by the highest power in the denominator, term in the denominator. So what did that mean by dividing every single term by the highest power in the denominator? So this is your denominator. So x is the term that have the highest power. One have the power of 0. So we're gonna divide every single term by x. Okay, so we're gonna divide every single term by x. So let's rewrite this. We're gonna have x approaching to infinity, 2 over x divide x minus 1 over x over x minus 1 over x. Okay, so look like I divide every single term by x. And then now I'm gonna simplify it. Limit of x approaching to infinity. This become 2 minus 1 over x over 1 minus 1 over x. Okay, so now why we want to do this, and you can now see clearly that when x approaching to infinity, this term right here will approaching to 0. When x approaching to infinity, this one is also approaching to 0. So we have 0, 0. And the turnout, the only constant that left when x approaching to infinity is 2. So we have the limit of x approaching to infinity of this function is actually equal to. And we can say the horizontal asymptote is y equal to. Some people also can notice or can find the horizontal asymptote directly from the function already if you still remember some basic concept in your pre-calculus. If you have the polynomial on the numerator and a polynomial on the denominator that have the same degree, then the horizontal asymptote is just the coefficient, the ratio of the coefficient. So what did that mean? So for example, if I have the limit of x approaching to infinity and I have x cubed per 2x minus 1 over 2x cubed minus 3x plus 4, right? So when I have the limit of these rational function right here, and I can see that, oh, the degree of the numerator and the denominator is the same, then the horizontal asymptote will be the ratio of the leading term, which is x squared, x cubed over 2x cubed, and that is 1/2. So my limit will be 1/2. The reason why we could do this because when x approaching to huge number, this number is just it's just smaller than the largest term. So we always take the largest term. We only focus on the leading term, and we take the ratio of that. This will give you the horizontal asymptote. Okay, and it happened to all the problem that have when your numerator and the denominator is have the same degree. So if I have 4x to the power 4 minus 3x squared plus 2 over 3x to the power 4 minus x plus 3. This is also same thing. We also look at the leading term and turn out our limit when x approaching to positive infinity will be 4/3. Okay, if this is approaching to negative infinity, the result will be the same thing because the negative number when you raise to the power 4 over the negative number when you raise to the power 4, they're going to be negative. I mean, positive become positive number. But if this is odd degree, it's going to be turn out the same thing. So if this is negative infinity, then you're going to have negative huge number divide twice of that huge number will be 1/2. Okay, so it will be the same thing if you have the numerator degree same as denominator degree, then we're going to take the ratio of the first leading term, or you can show the work like this.